So today we are going to discuss Mohr circle for plane strain. इसकी पहले हम analogy देख लेते हैं with equation of Mohr circle for plane stress. If you recall, this is general equation for normal stress at any plane, and this is the general equation for normal strain in any direction. So if you look at these two equations, the only thing that you see over here is you can see sigma x prime is replaced with epsilon x prime, sigma x with epsilon x, sigma y with epsilon y, and so on. The only thing that is different is you have tau xy in this equation for the sigma x prime, and in the equation for strain you have half of the shear strain. This is the only difference that you have in these equations. So similarly for the shear stress, this was the equation, and for the shear strain, this is the equation. The only difference you can note over here is this: we have half shear strain on the left hand side, and similarly this tau xy is now gamma xy by 2. We haven't derived these equations based on these equations. I mean, the equations for strain are not derived based on the equations for stress. This is not what I'm trying to say. What I'm trying to say is they are mathematically similar to each other. They happen to be similar to each other. So because of this similarity, most of the derivations that you have done for the stress transformation equations are also valid for the strain transformation equations, except with the difference as you can see encircled over here. For shear stress is now half shear strain. That's the only difference mathematically. Now this was the equation of Mohr circle for plane stress. By the way, this was derived by considering these two equations and eliminating the parameter theta and relating sigma x prime and tau x prime y prime in a single equation, and this is what we ended up. Now on this analogy, this is the equation for Mohr circle for plane strain. Alright, the only difference is where you find shear stress, it is replaced by half shear strain. I'm sorry, this should say gamma x prime y prime by 2. I'm sorry. Alright, this is not x prime y prime 2, this is gamma x prime y prime by 2. And similarly, this tau xy is now half gamma xy. Alright, these are the differences that I'm going to highlight. So at the center and radius of the Mohr circle for plane strain, alright, let's work those out. This was the equation that we had on the bottom of the previous slide. This was what I was referring to. This was gamma x prime y prime by 2 square, and this is what you have on the right hand side. So this could be written as epsilon average, epsilon x plus epsilon y by 2, and this whole term can be called as r square. So this is the equation of circle. So now you can see that the center of the circle will be having coordinates epsilon average and 0. But keep in mind that this time the two variables that we have is epsilon x prime and gamma x prime y prime by 2, not just not the full gamma x prime y prime. So if we'll see in the next slide how to plot Mohr circle for plane strain, but before going to that, just note that we will be having epsilon x prime on x-axis and half gamma x prime y prime on the other axis. Alright, so this center will have coordinates epsilon average and 0, center of the circle, and the radius will be, this, if r square is equal to this, then r should be equal to square root of this term. So this is the radius of the circle. So now as we discussed for the plane stress Mohr circle, if you have the center and radius of radius, then you can plot the circle. Alright, we will see how to plot a Mohr circle for plane strain in a while. So this is the general procedure. Let me show you. This is the x-axis on which you have epsilon x prime rightward positive, and this is the vertical axis on which you have half gamma x prime y prime. Now this point is the center of the circle. You will locate the center of the circle. This is epsilon average and 0. So you need to calculate epsilon average, and then on this axis you will locate this distance. So this distance is basically epsilon average. This is the center of the circle. This blue point is the point, this is your reference point A. Alright, this is your reference point. So the point A is the state of strain. Point A gives you information of normal strain and shear strain corresponding to 0 degree angle. Now, if you join these two lines C and A, this is what? A radius of the circle. And now you should be able to plot the circle. You have its center, you have its radius, or you can say you also have one of the points on the circle. So you should be able to plot this circle. We will see how we do this in AutoCAD in a while. And now, what do you see in the circle? How do you use it for the analysis? Now, once you have the center located and you also have the point A, which is the reference point, located. So what do you need to do in case of strain transformation? You are given epsilon x, epsilon y and gamma xy for a given element with having some reference orientation. As you can see over here, you are given this data and you are required to determine epsilon x prime, epsilon x prime, epsilon y prime and gamma x prime y prime. So in order to determine these parameters, you need to one way is to use the general equations that we have just discussed in our previous lecture. Use the angle theta in the equations and get your answer for epsilon x prime, epsilon y prime and gamma x prime y prime. But if you want to use Mohr circle, then if this x prime is at angle theta with x-axis, then in Mohr circle you will locate a line which is at 2 theta from the reference line CA. Alright, so this black point is giving you the coordinates epsilon x prime and half gamma x prime y prime by half gamma x prime y prime. Alright, so this B point will give you the state of strain for theta angle. Alright, so you need to go 2 theta from the reference line, and this point B will land on this point B will be giving you coordinates epsilon x prime and gamma x prime y prime by 2. Keep in mind this is gamma x prime y prime by 2. So if this value is let's say 75 into 10 raised to the power minus 6 gamma x prime y prime by 2, so naturally gamma x prime y prime itself will be double of that value, because half of it, you can read half of gamma x prime y prime from this graph. So this is something that you need to keep in mind. Alright, what if you are interested in the principal strains? So this point, as you can see, this orange point is giving this, the coordinates of this point are giving you epsilon 1, which is a major principal strain, and of course the shear strain on major principal associated with the major principal strain is 0, and you can see the angle of this point P1 with respect to the reference line CA, which is this reference line CA corresponds to 0 degree orientation. This CA line corresponds to this orientation. Alright, so this should be 2 theta 1, where theta 1 is the angle of principal strain, major principal strain with the x-axis, with the reference line CA. Alright, and this is second point P2 is giving you the minor principal strain, and of course associated shear strain would be 0. If you like, you can get the angle of this also with your reference line CA. This will be 2 theta 1 if you want, or sorry, 2 theta 2. Now what about the maximum in plane shear strain? This point can give you the magnitude of the maximum in plane shear strain, sorry, half of that value. So you know this can give you epsilon, the normal strain corresponding to gamma max in plane would be epsilon average. As you can see, it will have the same horizontal coordinate as the center, which has having epsilon average coordinate, and this will give, this vertical coordinate will give you half of gamma max in plane, and you can also see its direction like this. This will be 2 theta s. So this is what the concept is. Now let's take an example. Let's take an example and plot these values on AutoCAD. So let's take this example and perform it on AutoCAD, solve it on AutoCAD. This is the state, the problem says the state of plane strain at a point has components of epsilon x equal to 250 10 to the power -6, epsilon y equal to -150 10 to the power -6, and gamma xy equal to 120 10 to the power -6. So this information is given for this reference plane. You know epsilon x, you know epsilon y, and you also know gamma xy. And if you want to show the distorted element, deformed element corresponding to these strains, this is that element. We have discussed how to draw this element in our previous lecture. Now what are you supposed to do? You are supposed to determine the principal strains and the orientation of the element upon which they act. So first you need to locate the center of the circle, which is having coordinates epsilon average and 0. So you need to get the average of epsilon x, epsilon y. So we will calculate this. All right, let me show you in MathCAD also. This was the given data. All right, this is the given data, epsilon x, epsilon y, and gamma xy, and this is what I've just pasted from the book. Now you need to locate the center of the circle, which is having coordinates epsilon average and 0. So epsilon average is simply epsilon x plus epsilon y by 2 naturally. So this has been calculated to be 50 into 10 to the power -6. Now you need to know also the radius of the circle for plotting it on AutoCAD. So this is the equation for radius of Mohr circle for plane strain. Just note that this term is gamma xy by 2, not just gamma xy. All right, and now you have this value 208.806 in 10 to the power -6. This is now you have the center of the circle, you have the radius of the circle as well, so you should be able to plot it on AutoCAD using center and radius method of plotting. I'll be going to that in a while, but before you go to that point, let's also talk about the reference point on the Mohr circle, point A, which corresponds to epsilon x normal strain and gamma xy, gamma xy by 2. So A has coordinates epsilon x and gamma xy by 2. So epsilon x is directly given over here, so I just recalled that value. Over here, epsilon x, and we are given gamma xy, but we need to plot gamma xy by 2. So we calculated half of gamma xy. Now these are the coordinates of the reference point A. So we will be, because you need this reference point in order to measure the angle of a certain line with the reference axis. So you need to locate this A on your Mohr circle also. So let's start. Let me open an AutoCAD file and plot this. Okay, the first step is to move this origin. All right, move this origin to somewhere in the center of the screen, maybe here. Okay, now I want the y-axis, the vertical axis, to be downward positive, so I need to change that. For that you will type UCS, user coordinate system, and follow the on-screen instructions. It says specify the origin of your coordinate system. This is my origin. This is the line on which my x-axis lies, and I want my y-axis to be downward. So I've just, now this coordinate system is in line with what we want for the Mohr circle. On x-axis we will be plotting epsilon x, the normal strain, and on y-axis we will be plotting half shear strain, gamma x prime y prime by 2. All right. In order to draw a circle, you can pick this choice, this method, centered and radius. Okay. But before you do that, I would recommend you can go straight away, pick up a circle command and start drawing the circle. But I would recommend you draw this line CA first, and then draw the circle. This will be easier. Let me show you how. So I'll be starting with line command. Enter the coordinates of the center of the circle, 50, 0, and then I need to enter coordinates of the second point, 250 comma 60, I guess. Okay, so we have plotted this point CA. Let me show you it magnified. Alright, so this is CA, and what I'm going to do next, I'm going to plot the circle using center and radius method. So this is the center of my circle. So the advantage is that I no more need to enter the coordinates, because I can because with the object snapshot on, I can easily center point. Alright, so this was the end point of this line, and then it says what is the radius of your circle. So just you need to enter the radius of your circle. It is equal to 208.806. So 208.806. Alright, so this is the center. There you go. Center. The circle has been drawn, and you can see its center as well. This line is CA. Now what does the problem say? It says determine the principal strains and the orientation of the element upon which they act. So you need to locate you need to locate the extreme right point on the circle. For that, extreme right and extreme left point. So we need to locate this point, and we also need to locate this point. Line, and this is the first point, and maybe any point on this line, and because I'm going to trim this. Okay, and then another line starting from the center again, and okay, there you go. Let's trim it. I'm sorry. Okay, now you can see the angle as well. You can see the we will see that angle later on, but you can use dimensioning to see what is the major principal strain, or you can also use another option. Let me show you the other option today. You can go to utilities, you go to ID point, okay, and then it says which point. You say this point, and it displays the coordinates of the point over here, x equal to 258, as you can see. So one way is to but this will disappear after you have finished. This will disappear, you see, this will disappear. So you need to perhaps label it by using some lines. So let me draw some more lines, maybe starting from the origin this time. 0, 0, and maybe a line over here on this side, and okay, another line starting from the origin and in the downward direction. That's it. Now you can trim. Sorry. Alright, so this is the reference coordinate system line. These are reference coordinate system lines, and make sure you don't confuse the origin with the center. This is the origin and this is the center. Okay, now I can go to I'll do the dimensioning later. I can do it now. I'm going to switch the coordinate system once again so I can do the dimensioning, and then I'll come back to it. Sorry, it says UCS and origin, x-axis, y-axis. I have reverted the coordinate system again to normal, rightward positive and upward positive, because I'm going to start dimensioning. If you try to dimension it, if you try to label it with y-axis downward, it will the dimensions will be upside down. Mirror image banega. You will not be able to read it. We have seen this problem last time. So let me show you a linear dimension. Starting from this point, make sure that you start from the origin. The coordinate system is, the center of the circle is just one point, but when you are trying to see what is the value of this, you need to have it measured from the origin. All right, and this is the second point, and there you go. Maybe over here, this seems to be too small to read, but you can read it if you just zoom in. 258.86. You can also change the font by going to the text. Okay, you can change the font by going to the text. You have the option over here. You may do it yourself on your own. Okay, I'm going to label next the other dimension, the minor principal strain. So this is the origin, and linear first point, and this is the second point. So there you go. You can see it after zooming it. 158.81. Okay. Now, what about the angles of these the angles of these values, major principal strain and the minor principal strain? You can come over here to the angle, first line, second line, and you can see the angle over here. Okay, 17 degree. This is 2 theta 1. All right, this is 2 theta 1. Similarly, you can also see the other angle if you like, but one angle is enough. Now, what about the maximum in plane shear strain? You can locate it by drawing a line. By drawing a line from the center Okay, I hope now you can understand these commands. Again, go to the dimensions, linear, starting point, end point, and you can show it either on this side or the other side. Again, this is 208.81, okay, which was the radius of the circle. So this way you can label your Mohr circle showing the major principal strain as well as the minor principal strain, and also showing the maximum in-plane shear strain. This is, by the way, half maximum in-plane shear strain. So the actual value is double of this. So what you can do is you can just write these values over here based on what you have observed in your Mohr circle. Just bring them value those. If you like, you can, otherwise just pasting this circle is also enough. Okay, if you like, you can show up, so you can write these values over here, but if you want, okay, you will need to write these values over here because you need to perform some processing on these values, not for the normal strain but for the shear strain, because what you have obtained from the circle is half of gamma x, half of the gamma max. Okay, so let's show the values over here. 258.81 major principal strain है, 258.81, into 10 raised to the power -6. Similarly, you can define epsilon 2. Maybe you can just copy this and change accordingly this is 158.81 with a negative sign. All right, because it's on the other side of the, it's on the left side of the coordinate system. ठीक है, minus 158.81. All right, what about 2 theta 1? This is 17 degree. 2 theta 1 is 17 degree. So, or maybe we can simply say theta 1 is equal to 17 by 2 degrees. Okay, and if you like you can have it calculated as well, but ये रेडियन में बताने लग गया तो मुझे डिग्रीज में चाहिए. ओके, थीटा 1 आपके पास आ गया. नाउ इफ यू लाइक यू कैन ऑल्सो गेट थीटा 2. लेट मी शो यू दैट ऑल्सो. इसी को मैं कॉपी कर रहा हूँ. नाउ दिस वैल्यू वुड बी 17 plus 180. Okay, 98.5 degree. That's how this is theta 2, by the way. This is theta 2. Okay, now you have epsilon 1, you have epsilon 2, and theta 1 and theta 2 are also determined. Now what you can do next is, it's good to show them side by side. Epsilon 1 at theta 1 and epsilon 2 at theta 2. Okay, what next? Gamma max in plane. So gamma sub max in plane, sorry, in plane is equal to 208.81. Positive because it is downward. You can change the UCS again back to the same. ठीक है. Although आपने तो चूंकि जस्ट डिस्टेंसेस शो किए तो UCS को चेंज करने से, कोऑर्डिनेट सिस्टम को चेंज करने से कोई फर्क नहीं पड़ेगा. But this is what you can do. So it is equal to 208.8.6. If you like, you can also write R over here, R by 2, but you just need to be sure that you have shown it on the circle also. ठीक है, इसको आपने मैथ फॉर्मेटिंग में जाके इंजीनियरिंग में शो कर देना है. ठीक है, ताकि -4 -3 और -6 इस तरह से शो किया करें. ठीक हो गया. What about the angle of this? So let me show that angle. Theta S is equal to, let me show this angle. I haven't shown this angle as yet. मैं इसको इस तरह से शो कर लूँगा और फिर वहाँ पे मैं उसका नेगेटिव साइन लिखूँगा. ठीक है, मैं क्लॉकवाइज एंगल शो करने जा रहा हूँ. अब एंगल शो करना है तो अब मैं दोबारा से UCS चेंज करूँगा. I want to have the origin stay the same, but I just want to flip the y-axis. ठीक है जी. और अब मैं डायमेंशनिंग में आऊँगा. एंगुलर, दिस इज माई फर्स्ट लाइन, दिस इज माई सेकेंड लाइन. मैं यहाँ पे एंगल शो करना चाह रहा हूँ. सो दिस इज द एंगल 73 डिग्री. लेकिन ये माइनस साइन के साथ आएगा. क्यों? क्योंकि मैं क्लॉकवाइज डायरेक्शन में आया हूँ. दिस इज क्लॉकवाइज, यहाँ से मैं शुरू हुआ हूँ और इस तरफ में आया हूँ क्लॉकवाइज। इनके साथ यहाँ मैंने 17 के साथ पॉजिटिव रखा बिकॉज दिस वाज काउंटर क्लॉकवाइज। यहाँ से मैं स्टार्ट हुआ और इस तरफ में काउंटर क्लॉकवाइज गया। ओके, सो दिस एंगल इज 73 डिग्री, 73, लेकिन ये 2 थीटा एस है, सॉरी विद नेगेटिव साइन ऑल्सो, -73/2। ठीक हो गया। अच्छा, इसके साथ डिग्रीज लिखना चाहिए आपको, डिग्रीज। ऑलराइट, क्लियर है। अब आपने इससे मेजर प्रिंसिपल स्ट्रेन और माइनर प्रिंसिपल स्ट्रेन ये आपने इससे ले लिए हैं, उनके एंगल्स भी ले लिए हैं, गामा मैक्स इन प्लेन भी ले लिया, उसका एंगल भी ले लिया है। और अब एक और सवाल ये हो सकता है कि मसलन मैं आपसे कहूँ कि मुझे आप थीटा किसी और एंगल, मैं आपको आर्बिट्रेरीली कोई एंगल कहता हूँ, मैं आपसे कहता हूँ कि जी फॉर थीटा इक्वल टू लेट्स से 30 डिग्री आप मुझे स्टेट ऑफ स्ट्रेस बताएं, ठीक है, यानी सॉरी स्टेट ऑफ स्ट्रेन बताएं। तो आपको एप्सिलॉन एक्स कैलकुलेट करना होगा, एप्सिलॉन एक्स प्राइम सॉरी नॉट कैलकुलेट, लेकिन आपको मोहर सर्कल में शो करना पड़ेगा क्योंकि हम मोहर सर्कल मेथड यूज़ कर रहे हैं। सो इसका मतलब ये है कि मुझे जो प्लॉट करना होगा वो मुझे 2 टाइम्स, मुझे प्लॉट करना है 2 टाइम्स थीटा, ठीक है। अगर मुझे 30 डिग्री पे चाहिए तो मैं 60 डिग्री वहाँ पे शो करूँगा मोहर सर्कल में, ठीक है। आई वांट इट टू बी इन डिग्रीज। सो इसका मतलब मैं 60 डिग्री जाना है मैंने किस लाइन से, इस रेफरेंस लाइन से मैंने 60 डिग्री काउंटर क्लॉकवाइज जाना है। और इसके लिए आप पता नहीं आप लोगों ने असाइनमेंट में इसको कैसे किया है, लेकिन इसका आसान तरीका ये है कि आप इस लाइन को क्लिक करें। अब आपको ये 3 ब्लू डॉट्स नजर आ रहे हैं, 2 ये एंड पॉइंट्स हैं और एक ये सेंटर वाले पॉइंट्स हैं, इनको हम ग्रिप्स कहते हैं, ठीक है, ग्रिप्स। आप इस एंड पॉइंट वाला जो ग्रिप है सेंटर के साथ जो कॉन्साइड कर रहा है इसके ऊपर क्लिक करें। अब मैं आपके सामने दोबारा से कर रहा हूँ, इसको मैंने लाइन को क्लिक किया, एंड पॉइंट को क्लिक किया और उसके बाद मैंने रोटेट को पहले क्लिक करना है, ये रोटेट, और रोटेट के बाद अब मैं कॉपी और अब मैं रोटेशन एंगल इसको स्पेसिफाई कर सकता हूँ, ठीक है। अच्छा, रोटेशन एंगल ये मुझे देगा, अगर मैं इसको मसलन अभी 60 डिग्री डालूंगा एंगल, तो ये इसको काउंटर यानी फ्रॉम एक्स टू वाई जो सेंस बनती है ना, फ्रॉम पॉजिटिव एक्स टू पॉजिटिव वाई, उस तरफ ये प्लॉट करेगा, ठीक है। इस वक्त मेरा एक्स राइटवर्ड है, पॉजिटिव वाई अपवर्ड पॉजिटिव नजर आ रहा है आपको। तो अब ये एंगल अगर मैं इसको कहूँगा 60 डिग्री, तो ये इससे इस डायरेक्शन की तरफ मुझे कोई, इस डायरेक्शन को ये पॉजिटिव मानता है, ठीक है। AutoCAD का एंगल, AutoCAD का एंगल पॉजिटिव होता है फ्रॉम पॉजिटिव एक्स टुवर्ड्स पॉजिटिव वाई। तो अगर आपका पॉजिटिव वाई जैसे मेरा इस वक्त अपवर्ड है, तो अब मैं 60 डिग्री, अगर मैं एंगल इस तरफ काउंटर क्लॉकवाइज एंटर करना चाह रहा था तो मैं अब इसको पॉजिटिव ही एंटर करूंगा, ठीक। अगर ये मेरा वाई नीचे को होता और मैं एंगल इस तरफ चाह रहा होता तो मैं नेगेटिव वैल्यू एंटर करता, ताकि ये अगर मैं पॉजिटिव एंटर करता तो फिर तो ये मुझे फ्रॉम एक्स टू पॉजिटिव वाई प्लॉट करता अगर वाई नीचे होता ना। अब मेरा वाई ऊपर है, मैं जब 60 एंटर करूंगा तो ये इसी सेंस में एंगल मुझे देगा, ठीक है। सो अब मैं इसके अंदर 60 एंटर करूंगा और अब ये इस लाइन को प्लॉट कर देगा। दिस इज हाउ यू कैन डू इट। अगर आपको ज़रूरत हो तो मैं दोबारा से भी आपके लिए कर देता हूँ। मैं डिलीट कर रहा हूँ इसको मैंने सिलेक्ट किया ओरिजिनल लाइन को, CA रेफरेंस लाइन को, सेंटर वाली लाइन पे पॉइंट पे क्लिक किया। उसके बाद पहले आपने रोटेट वाली कमांड पे क्लिक करना है, रोटेट, फिर यहाँ पे कॉपी, और फिर कॉपी के बाद आपने रोटेशन एंगल, मसलन आप +60 एंगल चाह रहे थे, 60 एंगल आपने दिया और ये आपकी लाइन आ गई है, ये वाली लाइन। अब इस लाइन के यहाँ वाले कोऑर्डिनेट्स कितने हैं आप या तो डायमेंशनिंग करके चेक कर लें कितने बन रहे हैं। मसलन आपको एक लाइन ड्रॉ करनी पड़ेगी, आई एम सॉरी, आपको एक लाइन ड्रॉ करनी पड़ेगी फ्रॉम दिस पॉइंट अप टू दिस वर्टिकल एक्सिस, ताकि आप हर उसको शो कर सकें एप्सिलॉन एक्स प्राइम को। मैं आपके सामने करता हूँ फ्रॉम दिस पॉइंट सेकंड पॉइंट, और मैं इस डायरेक्शन में जाना चाह रहा हूँ ऐसे, ठीक है। अब ये लाइन ड्रॉ हो गई है और मैं इसको ट्रिम कर देता हूँ, सॉरी, ठीक है। अब आप इसकी डायमेंशनिंग कर सकते हैं, लीनियर स्टार्टिंग फ्रॉम दिस टू दिस, ठीक है। ये आपके सामने ये लाइन आ गई है 201.96, ये वैल्यू आपके पास आ गई है। ये आपको एप्सिलॉन एक्स प्राइम की वैल्यू मिल गई करस्पॉन्डिंग टू थीटा इक्वल टू 30 डिग्री। सो एप्सिलॉन एक्स प्राइम इज 201.96 into 10 raised to the power -6, ठीक है। इसी तरह से आप गैमा एक्स प्राइम वाई प्राइम को कर सकते हैं। मैं इसी को यूज कर लेता हूँ। उसके लिए आपको एक और लाइन चाहिए होगी, उसके बाद आप इसको ट्रिम कर सकते हैं, फिर आप इसकी डायमेंशनिंग कर सकते हैं, लीनियर फ्रॉम दिस पॉइंट टू दिस पॉइंट, ठीक है। ये आपका 143.2, ये हाफ की वैल्यू आई अभी, ठीक है, 143.2। और ये मैं वापस अपने यूसीएस को ठीक कर देता हूँ, ठीक है। और ये अपवर्ड है, तो ये हमारा तो अपवर्ड नेगेटिव है, हमारा तो डाउनवर्ड पॉजिटिव है, तो ये नेगेटिव वैल्यू के साथ आप लिखेंगे इसको। यानी ये जो वैल्यू है, ये तो चूंकि डायमेंशन आपने किए तो इसका तो प्लस और माइनस नहीं आएंगे, लेकिन आपको पता है कि मेरा डाउनवर्ड पॉजिटिव है, तो आप इसको -143.2 कर लेंगे। -143.2 डिवाइडेड बाई 2, इसके साथ इंटू 10⁻⁻⁶ भी आप कंसिस्टेंटली लिखते जाएंगे, सॉरी।